Okay, so today we will still focusing on the similar topics as last several weeks: the propositional calculus, the proof, the simplification, the indirect proof, direct proof. We can prove something's wrong. We can prove something that is true. Find tautology, contradiction. So it's very important to figure out these things because that's. In the second half of the semester, we will start using this sort of calculus, propositional calculus, to actually specify software, specify the functionalities of the software, specify the actual code. So we want to make this very clear before we proceed to next part. So today we will continue to do some of the exercises so that we can be more clear. We can have a better understanding of what we are actually trying to do. By the way, how do you feel about the midterm? How do you feel? It's hard, or so it's we're reading from 1 to 5. 5 is very hard. 1 is pretty easy. So what would you give the midterm? 5 is hard, 1 is easy.
2.
2. Okay, so not very hard, right? But kind of easy. Okay, so that's good. Yeah, that's good. So I want everyone to keep on track. So let's do more exercises on those proof, indirect proof, and when I was typing here, when I was typing the answer, the question here, if you feel something is wrong or you know the answer, just feel free to just interrupt and tell me what the answer is. Okay, all right. Now let's start with. Can I use this thing? This is gonna be easy. I don't know. Yeah. If you have the book, the work example 3.8, so on page 58. Okay, let's think about what we have learned. So we have learned all those rules, right? All those rules. All those rules. Like this, how to use them to simplify the and, the or, those stuff. Okay, and then we kind of apply those rules. We apply those rules to do. What can we do with those rules? If you try to memorize what we did, what we have done in the last several weeks, we did simplification with the rules, right? Right? Have we done that? Never heard that? What is simplification? Never heard that? Okay. The simplification of expression, right? So we have a whole bunch of long expression, right? So maybe A and B and A or B or C or D or E or F or G or true, right? So we can just deduce the true from that part with all those rules of inferences. Okay, so one thing we can do is simplification. As long as you can simplification is actually the first step of a lot of things. First, if you want to do proof, sometimes you want to simplify that first. Then you'll see it more clear about the logic there. Or if you are trying to, in practice, if you're trying to communicate with some other people, you're trying to find, if you find, sometimes you want to do the simplification first, then you find the contradictions there in your specification. right? You find this contradiction. Then what you can do is you prove something is true. We give you a whole bunch of expressions regarding A, B, C, and D. Then we want you to prove that. We want you to prove A, which means we want you to prove that A is true. Okay, A is the fact. So that thing, you want to use those rules to simplify. You have kind of value for something, and then you put them and mix those expressions. You replace something with another with already known value, then you can finally deduct something there. Or you kind of prove something that is not true, right? We can prove something is not true. Or and in order to do the proof, we use direct proof and indirect proof. What is direct proof? What is indirect proof? You done that? We all done that, right? We all did that. So direct proof, we have all those conditions and a result we want to prove. So we just try to deduct that result from all those given expressions, right? That's direct proof. So indirect proof, what's indirect proof? How do we do indirect proof? This important step of indirect proof, what's that? The first step. So another name of indirect proof is proof by contradiction. Proof by contradiction. So the very first step of indirect proof is we assume that result is true. No, we assume the result is false. We assume the result is wrong, right? So that's indirect proof. We assume the result is wrong, then we can, we assume the result is wrong, then we finally find some contradiction. So it's back to the contradiction. We use some maybe simplification or any transformation for those expressions. Then we finally find something that we find two things that contradict to each other, right? Okay, so that's what we can do, or what we learn to do with those things. And now let's do this. Let's do this. Yeah, if you have this book, page 58, book example 3.8. So a system specification contains the three sentences. So we know that there are three expressions we can generate from those three sentences, right? So let's see, what are those three? So the first sentence is, if the operator types the alarm command, then the subsidiary alarm will be activated and an alarm message will be written to the log file. Okay, when we read this sentence, we can find those keywords if, and, or sometimes we can find those keywords if and only if, right? If and only if. So those things will tell us how to transform from this natural language to the propositional calculus, the mathematical languages. Actually, when you read that sentence, sometimes you don't even understand. You don't even have to understand what does that mean. But you can still generate them. You can still transform them to a propositional calculus form, right? Like this: if the operator types alarm, if operator types alarm, okay, if, then we know something on the left side and then the subsidiary alarm will be activated, implies activated, and alarm message will be written, and alarm log, something like that. So the first thing, alarm command, right? Alarm, then subsidiary will be activated. We just say subseed, it's okay. Subseed will be activated, and the alarm message will be logged. So that's the first thing. Translate from natural language to this propositional calculus. Second sentence, whenever the subsidiary alarm is activated, the main valve is closed and shutdown is started. So it's the same thing as the last one. Like whenever alarm is activated, subseed alarm is activated, then a valve is closed and shut down. It's closed and shutdown is started. Number 3. If the main valve is closed and the reactor can be generated as being in a non-operational state. Okay, so it's valve closed implies non-operation states. Right? Just simple. So if then, so it's just the imply there, right? If the main valve closed, then the generator can be regarded as being in a non-operated state. Okay, so that's the thing. Okay, so the thing we want to do is express this sentence in propositional calculus. We already did, and also show that if the alarm command is activated, the reactor will be in a non-operator state. Okay. Let's see. So alarm command, this is what we want to do. Alarm command is typed, then we will non-operator state. This is what we want to prove. So we wanted to prove. Okay. So the thing here is so what we know is here from this, what we already know is this 1, 2, 3 expressions. And actually we know another thing. It's the alarm. It says if the alarm command activated, then it will be in the non-operational state. So for a non-operational state, we have this condition alarm, and we have those 1, 2, 3. Okay. So this is what we want to prove. What we want to prove is the true from this thing. So we want to have a 1, 2, 3 and then we have alarm is true, then we want to kind of prove this thing. Alarm implies non-operation is true. Alarm implies non-operation is true. Okay, we want to prove that is true. So basically it's the same thing as what we want to do here. Alarm, right? We know alarm and we know 1, right? And we know 2 and we know 3. You want to prove non-op. Alarm 1, 2, 3, non-op. It's true. So this is what we want to prove. We want to prove. Okay. So let's see. Basically, we have different ways to prove that. Some of them may be long, some of them may be short. It depends on. It's not necessary that you find or you always find the shortest way to prove it. As long as you can prove it, it's good, right? Sometimes it's just you saw this shortest way first, or sometimes you find a long way, but finally you will have because the logic is there. The logic is there. We can prove that is true. So anyway, if you go this direct there, okay. If you go here, like prove this way, a long way, then it's okay. But finally, you will have a truth there. Now let's see, how can we play with this thing? All right. So basically, it looks like alarm, and alarm implies blah blah blah, and subseed implies blah blah blah, and valve closed implies this non-op. Finally implies non-op. If we want to write it actually in a complete format, it becomes something like this, very complete. Very complicated. This, right? And this. And implies non-op. So this is the thing. For those things highlighted here, we want to prove this is true or false. True. True. If false, we try to get a false or contradiction when we're trying to say a contradiction, or we're trying to say a false when we are maybe. If you assume indirect proof, sometimes we find a contradiction. But usually when we're trying to do the proof, we prove this is true. We prove this is true. So how can we get this thing highlighted? Is here. These three things we transform from the natural language, right? And this one thing is the conclusion. Okay. So here, remember here. What we do is we have all those premises 1, 2, 3. We use and to connect them. And this alarm, remember, this alarm comes from here. It's like we already know 1, 2, 3 and this alarm. Then we can imply non-op. So this is the thing. We know alarm. We know alarm. Yeah, alarm. We know 1, 2, 3. We know 1, 2, 3. We use and to connect them. We want to imply, and then we imply non-op. we want to prove this whole thing is true, right? And this highlight thing is only we replace this 1 with this extra 1 here. 1, 2, 3. That looks pretty complicated, right? So we're trying to, when we are trying to do this, to prove this is true, when we find something complicated, the first thing maybe we want to simplify that a little bit, right? We want to simplify that, right? Assume this is the thing. If you want to simplify that, what would you do? If we look at this, let me give you a hint. T2L. You still have those the piece of paper I printed for you, the rules. Usually, see here, we want to combine those things that are similar, right? Like P1 or P1. We simplify that as P1, right? Those things the same. Or P1 or false. We simplify them as false, as a P1. And true. We want to have a true or false. Then we can deduce them. Sometimes, how can you get a true or false? It's here. See, usually when you have those P1 and the negation P1, when you combine them with or and and, you can easily get a false, true or false, right? And when you have a true or false, it actually helps you a lot, because this or 2 or 3, when you combine anything with a true or false, you will have something. You will have something simpler, right? You will have something simpler. So we're trying to find to see if we can see any P1 or P2, P1 or negation P1 stuff. Let's see if we can see anything here. Okay. Let's see how we can do it here. So first, let's to be simple. Number 3. We let me give you a hint. We are not using number 3 at this current stage. Instead, we will do this here. We will deal with this part first to see if we can actually simplify that a little bit. Okay. Now let's see. It seems we cannot just remove those brackets, right? Why? Because there's implication here. But we have a way. We have a rule that we can deal with implication. Remember? It's here. If P1 implies P2, we know we can deduce that, deduct the negation P1 or P2. So that actually helps you remove those implication. Why do we want to remove the implication here? Why? Because we want to combine those things together. We want to combine a similar stuff. Those variable with the same name, we kind of want to combine them together. If we have like P1 and P1, we know that just P1, right? P1 or P1 is P1. So we want to put things together. So but there's no rule to help you put things together with this implication signs there. So we want to remove this. Yeah.
If you have the second rule that is on the board, if you have P1, comma P1 implies P1 and implies P2, that's P2. Then if you have P1 implies P2, can it be P2?
What do you mean?
The second rule is on the board.
The second rule, yeah.
Second one. If you have P1, comma P1 implies P2,
Yeah.
which is P2. Then if you have just P1 implies P2, can that be P2? If you
No.
don't have the third one,
No.
it has to be P1.
If you have P1 imply P2, you cannot just say P2 because here it actually gives you an extra condition here, P1.
That means P1 and.
P1. No, it's not P1 and. It's P1. Not P1 and P1 implies P2. It's let me if we have any pen here. So let me write something here. So it's P1 implies P2. That basically means P1 and remember this bracket is here. The same thing as this. P1 and P1 implies P2. Okay, it's not something wrong here. This is wrong. P1 and P1 implies P2. Okay, this is wrong. This is correct. P1 and P1 implies P2. Okay, so what's that? What does that mean? That means, okay, we know P1. We know P1 implies P2. Then we know P2. Why? Let me give you an example. Let's say P1 is just give me a if else if then. Give me an example of if then. If you're doing well, you will get an A. Okay? P1 is if you're doing good in this course. P2 means you will get an A. If you're doing good in this course, you will get an A, right? And another condition here is P1. We know P1. We know that you're doing good. Then we imply that you will get an A. Remember? But this whole thing here is P1 implies P2. We know the first condition we know is you are doing good. The first thing we know that you are doing good in this course. The second thing we know is if you are doing good in this course, you will get an A. Then can we know you will get an A? Yes, because you are doing good. We already know you are doing good. And we also know if you are doing good, you will get an A. Then we know you will get an A. Right? Does that make sense? Okay, so that's this implies.
That means we have to put parentheses in between that to represent it.
Yeah. That's another rule. That's why I'm saying you need to be familiar with the rule. See here, P1, comma P2, P1 and P2, right? And 5. See and 5. Okay, let's go back to what we were doing. P1 implies P2. Negation P1 or P2. That's a quite frequently used rule for us to get rid of that implication symbol. So here, now let's see. What can we do? Okay. Alarm And what shall we put into this? Negation P1 or P2. Remember? Negation P1 or P2. So it's negation alarm. Did you see something excited? We said alarm and we said negation alarm. There's a potential there. We can combine them and remove something, right? It should have that sense. So it's negation alarm or negation P1 or P2, right? So or, what should I put after this or? This rule. P1 implies P2. We have a negation P1 or P2. Here, alarm implies succeed and alarm message. We have a negation alarm and succeed and alarm message, right? That's great. Okay. We actually need brackets here, but it's not necessary here because the and has a high priority, so we can just leave it there. But when we want to be more clear, it's better to put it here. Okay, and then this end here goes here. The succeed implies valve open and shut down, right? So here let's do negation succeed or succeed. Which one? Yes, negation succeed. Let's actually do something like this. Okay. Alarm. We use A to represent alarm. Okay. We use S succeed S. Okay. And alarm message. Alarm message. Valve close and shut down. And valve closed and shut down. And non-operation. So this is VC is yeah, I'm doing this because I want to make it shorter. The expression is shorter. Okay, so this part has no problem, right? It's just the abbreviation there. Yeah, I just want to replace them. So here we become A negation A S AM, right? And here is succeed, negation succeed. So negation S, negation P1 or P2, right? So here is valve closed and shut down. So it's valve closed and shut down, right? And then we have and 3. We didn't touch this 3 yet. I'm just to be simple. I'm just telling you that for this 1, 2, and this alarm, we can have something to do. So, but sometime if it's too complicated, you might want to put the 3 inside as well. Implies what? and O, right? Yeah. Great. Great. All right. So here we have this kind of complicated, but we do see some hope there, right? This negation A and A, yeah, we saw that. We saw S, we saw a negation S, and something like that. Oh, yeah, something like that. And here, let's see. Okay, so now let's see what else we can do here. If we are trying to let me see. 1, 2, 3, 1, 4. Yeah. So here, if we want to kind of combine them together, we should see how can we take off those brackets, right? So if we look at this rules here, basically it's distribution. We kind of put this thing outside, inside, or then combine things like that, right? So well, let's see if we can do something like that. Okay, so here we kind of want to maybe A and negation A, we want to put them together, right? No matter it's and or, if we put them together, we will have something, true or false, right? So be sensitive about this. A and negation A. A and negation A. We want to put them together. So what do we do? What rule are we using? Distribution. Distribution, right? Yeah, distribution, because this is the only way we'll put this A and negation A together, right? Yeah, right now it is the only way. So it becomes, we are using distribution and or. This distribution and or, kind of this is like an A, okay? So it becomes A. All right, tell me. And negation A, neg A, right? Then or A and this thing. We actually don't care about them right now, and then the rest of them we just copy paste. Okay, I'm not putting all those the rules we applied there. I want to be faster. If you want to see, yeah, we talk about what rule are we applying there. If you want to have very specific what rules are you using each step, you can refer to the book. But here I'm trying to establish the sense here. So I will neglect the step that putting all those specification of the rules. Okay. All right. So here we know what we know is maybe A and A. We got A and negation A.
Well, that obviously can't be.
What's that?
That's false.
Yeah, A and negation A. Let me find out the official name.
Contradiction.
Yeah, okay, contradiction. Yes, contradiction. A and negation A. Contradiction. Actually, okay, you know that if you do not look at these rules of inference, you should know A and negation A is false, right? Because if A is false, negation A is true. If A is true, negation A is false. A false and a true is all false and true always result in a false, right? So that's some sense you should have in your mind instead of checking everything from this rules of inference. So this becomes a false, right? So this becomes a false. So it becomes a false or something, right? False or something. So this part we put them together because this is the end here. So basically we calculate this part and we OR this false. Anything OR false becomes that thing. Okay? Anything OR false becomes that thing because if you are trying to decide it's P1 or false, deduct to P1 because it all depends on P1. If P1 is false, the whole expression is false. If P1 is true, the whole expression is true, right? P1 or false. Make sense? Make sense? Yes. Great. False or something. So that's like false or P1, right? So we can just get rid of this false. We only need this part. Make sense? Make sense? Right? Okay, and here what we can do is see we have this and although we have this brackets, parentheses, it doesn't matter because that's all and, so we can just remove them. So that is because of the rule here. See? You can flexibly group anything or ungroup anything if it's all and, if or it's all or. Okay, because they're the same. They are the same. A and so it becomes something like this and 3. But here we cannot remove this brackets because that's still something we need to apply some other rules, right? Here, because this is or, this is and. We need to apply. We cannot just simply remove this bracket. We need to use the distribution rule, right? To do that. So it becomes things like this. Right now, no. Okay. So this is fair enough. Let's go to the next step. ASAM. Here we have SVCSD. Okay. Let's see. Okay. Now let's see this thing's inside. Oh, it's actually an and, yes. And then it's this part here. We use the distribution. Yeah. Okay. Oh, sorry. What's wrong here? There is a group here. Yeah, we cannot just do that. Oh, sorry about that. Okay, so when we are trying to do this distribution, we remove this brackets. We put this A and inside this OR. We kind of need to still group them together. Because here, if we do not group them together, this AND has a higher priority, right? So we have a group here, from here to here. This part. Okay, this part highlighted here comes from here. A and negation A or S and A. This part. Okay, so this highlighted part comes from this part. Because they are integrated part, so if we like trying to decompose them, we still need to have this group here to make sure this part will be calculated before this end. Okay, all right. Yeah, sorry about that. So this, since this part becomes false, yeah. So since this part becomes false, this actually becomes false or something. False or something, right? False or something, not false. Yeah, become this something. Okay, false or something becomes something. That's a nice expression. So this whole part deduct to here, and then we have this, right? And then we can just remove those brackets. And then let's try to deal with this part. Oh no, it's actually, now we have this part, right? We have this part, number 3, this part. We reach here step by step. Okay, no problem here right now, no problem. Okay, now what we can see is here we have and, right? So what can we do? And what important is, we saw an S and negation S. What do we want to do? We want to try to put the S and the negation S together, no matter it's an AND or. Then we can have another true or false there, right? If we have a true or false integrated inside, then we kind of help us a lot, right? So, but here we have and this thing. If we want to put S, and with this S, we can just remove those brackets because this and this, they are all AND, right? So if they are all AND, we can just remove that brackets, or we can just remove this group, or this thing, right? So here it becomes something okay, maybe we put S here, and we can exchange the order freely, right? According to the rule. I forgot what's the name, but some rule. Okay, yeah, commutation, something. Okay, then we put this. This is awesome because we see that S is here, and then we want to put this S with this S. Let's group them because they are all N, right? We can group them. We can just group this S here, right? Any question? Problem?
Why not 2 equals 3?
It's same because we want to keep this part simple. We just want S with this S. You can put it here. It's the same,
Okay.
actually. Yeah, because they are and, right? Then we find a way to put S and this negation S together. It becomes S and negation S. Negation S, or S and, right? Right, so we saw this. We saw this. Huh?
There should be parentheses after the S, not the next S.
This
Yes, there should be parentheses.
here.
Yes,
Why?
because that S is multiplying what is inside it. It's multiplying BC.
It's not multiplying. That's
Is
multiply is we're talking about different things. Multiply is, yeah, I know what you mean. It's this is different thing. So it's S and. If we see this VC and SD is the whole part, so what do you want to say is this, right?
yes.
But
So is yes.
okay, yeah, it should be. It can be that. But this and we can remove those brackets, right?
Yes.
So we can just remove them. So it becomes something like this. Okay. To be more clear, let me use this. Okay, so this is 3. Okay, so it becomes A and AM. And this whole thing. And 3 implies NO. So here we see, but inside this, there are two parts. One is S and negation S, right? S and negation S, right? Or S is blah blah blah. We cannot do anything here because that's basically just it. Okay, but S and negation S, true or false? False, right? So it becomes another round of false here. So here this whole thing becomes false, right? All right, what do we see here? It's a false or something. False or something become something. Becomes something. So false, we can just remove it. False or something becomes something, right? Okay, so what we see here is A and AM, and inside this is S and VC and SD and 3, right? Because they are and, so we can remove this group, get rid of these groups, right? That's all and. N. So we don't want them now. Okay, number 6. Now it looks much better, right? We only have 1, 2, 3, 5, 6 things here plus this number 3, right? What's this number 3? All right, let's see what is number 3. Number 3 is VC implies non-op, right? VC implies non-op. Yeah, so it becomes VC non-op. VC implies non-op. Okay, so VC implies non-op. You don't have to write down all this thing. So you can find them here. I want you to have this idea. I want you to hear my explanation of that. So you don't have to write it down. It's all here. So okay, we have a VC implies an O implies an O. Then what do? We saw imply there. We kind of want to use a rule to get rid of the implication, right? P1 implies P2.
So not VC.
It's
Or
non-neg P1 or P2, right? P1 implies P2.
Negation of
so just obvious,
Yeah. So it become neg
which is going to be false.
neg P1
Because of community laws.
or
False or no.
no,
Implies no.
right? Or no. Okay, then we saw something, other thing that is pretty exciting. We saw negation VC and VC, right? And we see this is our N, so we can just move this VC here, maybe a little bit closer, look closer. Right? So we put this VC. So this step is okay, right? We just put this VC from here to here because they are all N. So we can freely, flexibly move and adjust the order. Okay, and because they are all N, we can freely group them. We want to group this VC and this part. Okay. Problem. We want to group this together. Can we group it?
Yeah.
Yeah, because they are all N. See N, and this whole thing you see or here, yes, but this whole thing negation or NO, we can just maybe we call it P1 or P2, P3, P4. So it's like A and AM and S and SD and VC and P2. So we group kind of like we group P2 with VC. Things like this. We just can give it something, some name there. Okay. So we can group this part. All right, we group this part. Then it's a VC. We use the distribution. Okay, I'm not writing it out. Just we can do it in our mind. It's going to be VC and negation VC, or VC and O, right? So we saw a VC and negation VC. It's become
False.
yeah, false. So it's VC and negation VC, VC and O. something like this. Okay, number 8. So this becomes a false. A false or something, right? Another wrong. A false or something becomes something. Yeah. Yeah. So it becomes something like this. And oh, any problem so far? Okay, and see, we see all those are and. We remove this bracket. Clear. So clear. All right, number 9. What do we do? It seems nothing to do, right? It seems there's nothing to do now. But we saw NO, 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 NO. However, there's implication. Again, we use the implication, the implied rule. Let me see. Yeah. So just a negation. We negation everything. Negation P1 or NO, right? So it becomes negation. Okay, negation. Then we're trying to put something together. Okay, here we just want the NO. We just want the NO and this NO. So how about let's do some group, because they are N, right? So here we group those together. So this becomes number 10. The negation of this part. Or, come on. Or negation NO. So this highlighted part comes from here. We put the negation inside. Okay, no problem. If we want to put negation inside, you put negation in front of it, and you change this N to OR, right? Change the N to OR. So this is a group. OR NO. Okay, we're almost there. We see some hope. NO, 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 negation NO, right? Then, okay, since they are OR, right? So it becomes, we can just remove this group because they are all OR relationship, or, right? It's the same thing if you group them or not, right? So, what's the question?
Why you just remove?
see here, this is OR. This is another OR. Right?
Yes.
They are all ORs. So before I remove it, it's something like this. Right? But we saw here, these are all OR. That they are all at the same level. So we know this. And then we can group them. What is this? Neg NO or NO?
True.
Only one knows this is true? What is negation NO or NO?
You know,
True.
True. True. Right? So give any value to the NO. If NO is true, we have a true here. If NO is false, negation NO is true. We have true in this OR. True. Okay, so it becomes this thing. This thing. Or true. So do we finish?
true.
Yeah, it's a true. So what is the name of that rule? Anything or true becomes true. Or two.
What about the negation at front? Do you have to consider that?
This negation is for this part only. You know, negation has the highest priority. So it has to calculate with the thing that immediately follows it. So this whole thing becomes P1. P1 or true becomes true. Okay? True. Alright? Okay. So we spent a whole class. I want to build you to develop some sense that how should we actually apply those rules. The rules are all there, right? And we know the steps. We know S1, S2, and S3, and then we want to have a conclusion. But how can we do that simplification? How can we deduct from those complicated stuff? So here for this, it actually does. It makes a lot of sense because there's some key stuff there, like negation A or A, negation A and A. So something similar. You put them together, you can have a true or false. Then when you have a true or false combined with and or, you can further reduce those things, right? Some false or something becomes something, something like that, right? And then we finally have here something or true becomes true. Okay, so so I want you to build that sense, and maybe after you go home, practice just the same question. Try to practice it without looking at this answer here. But you can have this rules of inference there. Rules of inference there. Try to practice this until you finally can like solve this proof problem without looking at this part answer. Okay. All right. Thank you very much for today.